Welcome to everybody, and I'm so glad to see the sea of hands, and I didn't necessarily acknowledge individually you when I start my presentation, but I will have pictures of your buildings, so some of them at least. So the first mass timber, current modern mass timber building that we are aware of is in Hilton Head, South Carolina, and it's a house, and it was constructed in 2009. So we're talking about a relatively new product that's here in the United States that just replaces old beams, heavy timbers. Do any of you have a heavy timber, old heavy timber building, post and beam kind of building on your campus? Okay, so we have about 4 of them on ours, and we've now stripped away all of the acoustic tiles and are revealing those beautiful wood beams. So it's been really fun at Clemson to do that. So let's get started. So mass timber, it comes from trees. Yes, that came up earlier today. But as we talk, I want you to know that the South's third largest wood basket is in the southeastern United States. And there is no way that at this rate we are going to cut enough of it to make hardly a dent in it. We literally, of the annual growth of the forest in the South, for example, when you look at it, if a tree grows, all of the forest grew a ½ an inch a year, we would only cut a 1/4 of an inch a year. So it's still compounding kind of its interest rate. So our growth keeps going and going and going, to the point where we are quite worried about the state of the forest and the forest management and the resilience of the forest as we go forward in climate change. Now, does anybody believe in climate change? Okay. If you don't, look outside. Because prior to current times, probably somewhere post-glaciation, the subject species loblolly pine, which is the largest species largest amount of species of pines in the U.S. South, actually emigrated from Mexico. There was no wall. Not sure what the river looked like, but it emigrated from Mexico and moved into the southeast. One little pocket, because of the environment in this area, stayed here, and the rest moved almost to Huntsville before it started up again. So the area is called the Lost Pines because this is the one remnant population of pines that didn't move with the rest of them. So a very unique area. Climate was much different, and the world changed. And as a forester, and I think much longer than most people, I think thousands of years when I think about forests, I know it'll do again. So I'm a firm believer that climate changes. Just wait. So the key principles, and this is a private landowner's land in the upper right-hand corner there. He loves pine trees, and he loves beautiful pine trees, and he manages well. He's an orthodontist, convinced, converted, sold, loves it more than even I do. And the key components of mass timber that we tend to work with in the U.S. are glulam beams, which you can see in the upper picture, and cross-laminated timber panels. So they're 2x6s that are connected together, laid out long, glue goes on, lay them crosswise, glue goes on, lay them longwise, glue goes on. So they're becoming the equivalent of a precast concrete panel, but about 1/5 the weight or 1/6 the weight, very exacting. It's maybe 1/4 of an inch difference in measurement from one end to the other, over 50 to 60 feet long. So very exacting. What you see down below is our first mass timber building on the far right. That's the Andy Quattlebaum Outdoor Education Center, and that's its picture in construction above it. And then below it is the new building I'm working on. It's our first academic building in mass timber. This is the new Forestry and Environmental Conservation building. And there we're going to premiere a lot of mass timber on the interior, and it will be southern yellow pine. So let's move on. I want to talk about the versatility of timber. So I showed you the exterior of the Andy Quattlebaum building. On the right, you can see the interior of the Andy Quattlebaum building. but you can dress it up. So shortly after it opened, we held a black tie event to honor one of our highest award the university gives. We have a big medallion event. And so we went out to the Andy Quattlebaum building and had the party for that building. So you can go black tie or you can go canoe. It doesn't matter. So it really is pretty. And the large, tall column in the middle of that building is actually an elevator shaft. And if you do nothing else in a building, a wood elevator shaft is really great. Why? Because you can go up in a day and a half or less. You can do a 60-foot high elevator shaft in a day and a half. Easy peasy. The elevator people love them. There's no shimming, there's no messing. It's just there. It's beautiful. And by the way, it will meet a 2-hour fire code. So, now, why build mass timber buildings? Well, the first is if you have a net zero or embodied carbon platform on your community or your campus, you are going to store more carbon by like a lot than it ever takes to process it. And one day, some of us would love to see a carbon registry where we actually have carbon that is trees growing in the fields sucking up carbon that people get paid for. And then those of us who build our buildings out of carbon, oh, by the way, maybe we get a little funding too, because we're going to store carbon in that building for a long time. I heard this phrase today, we'd like to build our buildings and plan on a 40-year horizon for their lifestyle. I want to build mass timber and have them last as long as my heavy timber buildings on campus. And I know one of the youngest ones was built in 1908. So I want a 100-year building. So we want to build where it's flexible, renovatable, and resilient. And we think that wood gives us a great option for those things. Flexible, renovatable, resilient, and also built of a renewable material. Now, we always hear, but it costs more. It costs more sometimes on a square foot cost of 1 square foot of wood CLT versus 1 square foot of concrete or steel. But we're looking at building costs. So when you put these buildings together and you get the basic structure up, there's possibly 8 people putting the structure together. I bet on a steel or concrete building, you're looking at 25 plus employees on site at any one time. So we've already lowered your labor costs when you're going to build with wood. The construction site, if you have been to Pennsylvania, the University of Pennsylvania, I think I've got a photo in here, is building in the middle of the city on one of the tightest lots I've ever seen. There's no way you could do it with steel and concrete, but with mass timber, they literally blocked 1 lane and they've set up their system such that the truck comes in, goes in that lane, they unload directly from the truck and up onto the building, and they have no lay-down yard at all. And if you do it right, you won't have a lay-down yard. So this is a clean construction site. There's no waste. Everything fits together just like Legos. And it's an incredible issue when you are building in a tight building site. Speed of construction is really large, or really fast. Chuck told me 14 days for your building. He'll verify that later. If you've got bad soils, these aren't heavy buildings. So literally you can put down a concrete pad and go up because it's not heavy. It is not a heavy structure. So poor soils, this is an option. Donor requests. So anybody from Auburn? Auburn they were building a culinary institute. Their donor owns Yellowwood, which is a pressure-treated wood preservation company. And he built $30 million for the donation. And they said, oh, by the way, we can't really do this in wood. And he goes, I don't think so. And it went to wood. So the Culinary Institute, the food court, is all wood there. So part of the building is not, part of it is. But when we see this, people really appreciate it. The architects tell me they don't get calls about their buildings unless it's wood. We think it helps forest health. We think it's related to climate change. Definitely labor and sustainability, so all good things. And that building, by the way, is an environmental chemistry building at the University of Nottingham. And the spikes out the top are where all the vents go for all of their hoods. Now, this is a traditional timber building in China. So when we talk about durability, everyone goes, it's not going to last. This building is over 800 years old. I bet it outlasts the buildings behind it. Because I can tell you in that city, the older concrete buildings that they have a lot of, their residential buildings, are actually on the side of the river where this building is, and they already look like they're falling apart. And this is a city of 7.5 million people in the interior of China. So this is not the Summer Palace or one of the more famous buildings. You have to actually go find this building. Today's academic timber buildings. I thought I would just run through a few of these. The first are the University of British Columbia. It is an 18-story building, record fast construction. I think they put up all 18 stories in less than 3 months. The second one over on the left-hand side is, my left, not y'all's, is their biomass power plant. So yes, they have a biomass boiler, and they run it from that, providing steam heat into that region. Wofford University, they built one, they finished or began theirs just as we finished our first building. This is their environmental science building. Does not look like a wood building until you walk in. And then it's all wood. So that's what it looks like at San Jacinto State. Chuck, this one's yours. That's the interior of their academic building. Very successful. I love the clean lines. You did a great job on hiding all your utilities. It was great. And we too, in the Andy Quattlebaum, have the double glulam beams. So you don't have to have such deep glulam beams. You can double them up like they did. And you can run a multitude of things between those beams. This is University of Idaho. I think somebody's here from Idaho, right? Right. Love it, love it, love it, love it. Great, ambitious project. Began with a small grant from the Forest Service to the Forestry Department, and the idea was conceived and put together, and it is an awesome building and a type of building. Rice University, right here in Texas, this is a residence hall. I'm just showing you the types of buildings you can do. Warm, traditional kind of residence hall, but the warmth of the wood really sets this aside. You see more here at the University of Arkansas, and then the buildings, the two stacks together. Those are actually a mass timber archives for that university. So they needed a new archival storage facility. So it too is mass timber. So they're trusting their most important documents into a mass timber building off campus. They're also building, by the way, a new architecture building that will be mass timber. Here's that University of Pennsylvania Data Science Hub. That, my friends, is a very tight spot. But this is where all of their new incredible advances in data science are happening, and they needed this building, and it fits right there in the center city of Philadelphia. Oregon State academic building for forestry, and then they have a lab, I think also, which is in the second picture that's there. So, okay. University of Mass Amherst, one of my favorite buildings. Thank you so much. We got our glass ideas from you. We came and visited. We truly appreciate you. Love this building, absolutely gorgeous. And it's just incredible. A really nice piece of engineering, originally designed in steel. And they decided, let's think wood. And they went wood, and it came out below cost, maybe not under budget, but it was equivalent. You know, it's not like they decided to go whole hog and go crazy with their budget, right? Yeah. Everybody loves it. You love to tour it. Donors want to see it. People want to be there. Events get held there. Name it. Michigan State. Anybody here? Yep, STEM complex. Right? All mass timber. Love it. Everybody enjoys living there and being there and teaching there. Any acoustic issues? Thank you very much. Everybody, oh, but the acoustics. Well, I'm telling you, concrete is much worse and glass are much worse for acoustics, in my opinion, based on my evidence. That's my personal evidence, not an acoustic engineer. So dispelling the critics. So if you line up here, everybody goes, well, the wood costs too much. But the total building cost, when you do it right, can be less. I'll tell you what we saved on the Andy Quattlebaum. We didn't put a single gypsum board in the ceiling. There's no acoustic tile in the system ceiling. All of the wood is exposed. Wherever we can expose wood, we exposed wood. That was $100,000 in predicted cost savings for us, just not having that up there. And now we don't have to paint it or worry about it. It's beautiful and it looks great. So it causes deforestation. If I were in some world, some countries in this world, it might cause deforestation. But it is not causing deforestation in Europe, where it's more used than we are using here. And certainly, based on the estimates of the big wood baskets, i.e. the southeastern U.S. and the Pacific Northwest, it's not going to cause deforestation. We have government regs. Many of our forest landowners who are privately, 53% or so of the forest land is privately owned. They want to own their land for a long time. They're committed to reforesting, and we can really look at it. And if you actually want to know where your wood came from, if you know this sawmill it came out of, there's actually online a little system where you can go and look. I'll show you our building later. I know where every sawmill it came from. I know the area. I know there's more wood than they know what to do, and I know, because I know those areas, I know that they're pretty much practicing sustainably managed forestry there, and everything is a really good thing. So it's rural economic development by buying trees from these people. It's regrowth of forests. It's opening up closed canopy stands so that we have habitat for non-migratory or migratory neotropical birds. It's opening up habitat for turkey and deer and other animals. And I worry about those things. I worry about all of those endangered species and plants. And that's all got to be covered. And we are, you know, we're pretty much working on all of those issues. No one knows how to build it. More are knowing every day. And I will tell you that if probably when Chuck and UMass Amherst, you had Nordique helping you though. If you don't work with a group that knows what they're doing, there are groups, there are large construction companies that actually have mass timber specialty groups. So for example, Swinnerton is a large builder in the United States. They have created a whole group called the Timber Lab, and they will buy all the panels and do all the glue lambs and have it all shipped, ready to go, and put it together for you. DPR has a mass timber group. Skanska has a mass timber group. There are more and more every day. As one of the Skanska guys said for us in a seminar the other day, they really do know how to do it. They just don't know that they know how to do it. So when they got their crews in, they were able to do it. And so they just said, well, look, and it's easier to train. You basically have a screwdriver that you hold here, and you feed the screw into it, and it goes, and you're done. You know, it's pretty easy. Or you've got these wonderful, incredible connections that just slide on top of each other, and then is wrapped in wood, like with 1.5 inches of wood around the connection, so one slides right over the other, and you've got an hour-plus fire-resistant connection. You don't have to treat the steel, because the steel is not fire-resistant, but the wood is, and it will protect it. My architects did not suggest it. Did you ask for it? Because when we first got started in this, no architect would have suggested it. When we went out with our first building, I convinced our team at the university facilities that in the RFQ, they had to write, we want mass timber. And so they got it, and we got a great architect that did it. My building official is reticent. Well, the first thing we're going to do is, well, I'm lucky our building official is on campus, so I can talk to him. But yes, I had to go meet the state engineer in South Carolina and warm him up to this subject, but I began doing that in about 2014, 2015, and by the time we built our building, he was like pro-mass timber. So it really works when you start working on ADM Street in Washington, D.C. Anybody here from GWU or someplace like that? GW. Okay, so when you're in an inner city and you don't have a lot of space, what are they doing in Washington? They just built 2.5 stories on top of an existing building. So now instead of a 5 or 6 story building, they've got a 7.5, 8.5 story building at ADM Street. Perfect solution, and I understand that the Washington, D.C. municipal authorities are all like, bingo, this is the way we can expand in our city, bring more tax dollars, more occupants, more businesses into our city, and not be having to scrounge for space or tear down things that we didn't need to tear down. And it was an economical effect for them. Is it strong enough for my use? All of the design guides are out there, and we're constantly working on this, so that is not an issue so much. And there's engineering support, and because not every engineer was trained in wood, let me just tell you, most schools don't teach wood engineering. Working on that too. And in fact, they don't teach wood architecture. But enough help is out there, and I'll show you a slide later on about where to go get that help. What about? All buildings have issues. All buildings have issues. And so one of the things that my friends told me a long time ago in architecture was the envelope is the seal of a good building. If you don't have a great envelope and you don't take care of the envelope, it doesn't matter if it's wood, concrete, or steel, it will go bad. So my mantra is a great envelope is the key to any building. Now, all of them have issues, and you just got to find the right one. The other thing I always say to everybody is wood is not in every building. It shouldn't necessarily be the only component in every building. And in fact, a lot of our buildings are hybrid. They're concrete below ground. They're concrete toppers on the floors, on the CLT, on every floor. There's sometimes steel beams if you want a wide open space because there's a limit to how wide you can go with glue-lam and post and beam situations. So there are limitations. Use the best material for the correct job, and you can, combined with all of your savings in embodied carbon with the wood, come out with a structure that is probably net zero on the structure. So innovation. So we've done more performance testing for fires. We've burned up a lot of things. Every new connection gets fire tested, it seems. Compartments get fire tested. And frankly, the building codes have edged up to now we can not only, by 2024, you can keep ceilings open in even 18-story buildings. Now, there are lots of ways to build these buildings. They're easy to build them as type 3s. Type 4s are a little bit more difficult, but they are there, and you can go solid mass timber up to 18 stories. Milwaukee has the Ascent building that just got opened up about a year and a half ago, and the owners of those buildings are already announcing that they're going to go with 15 more of those, I believe, across the nation. So can be done. They believe in it, and they're going. Seismic performance. The story here is a 10-story shake table test. Colorado School of Mines, Ling Pei is a scientist there, and a whole group of people from around the world. They have tested these wall systems. That skinny little building is all mass timber. They've come up with a rocking wall system. Nothing broke, including the windows in the external portion of the building when they tested it. And they tested it over almost every earthquake known to man right now that we have the actual measurements of and can repeat. So yes, these buildings can go in high seismic zones, and because of that, we're going to find more and more that are going to have to be less and less having concrete cores for the center for against seismic codes because of some of the changes that we've seen here. This is an amazing breakthrough that this happened. I mean, if you watch, you can go online and watch those tests. They'll blow your mind away if you're into that kind of thing. Again, there's a lot of research going on in durability and building physics. We're still doing a lot of architectural and structural research, construction research, really learning how to do it. The most important thing about these buildings when you're doing the plan is that you need to have a BIM model with full 3D design. Every subcontractor's design needs to fit into that BIM model. Why? Because every hole is already drilled before it ever comes to the site. So if your electrical contractor wants to run a conduit, it's right there. All he has to do is move through it. Everything is there. So it's really easy. Racks fit well in this when you're looking at stuff, so it really works well. The structural system design and performance, we're continuing to test that. There was a lot of question about vibration. Oregon State University, I think, is building a new lab building not on the main campus, but over another campus, and that is going out with, so that people can't say, oh, we can't do labs anymore. So overcoming the obstacles. It really does take thinking, planning, doing all of the things that you've got to do. You've got to accentuate the positives when you want to build one of these. Find champions to support it. For example, in Florida, I know the state forester is like going gangbusters trying to convince the University of Florida they need to build one. They've even called me to ask if I can help. So I just did. We talked. If you've never been in one, there are mass timber structures all over. Please go ahead and get ready. Go see one. There's places to find them. How does this fit into your sustainability policy? How does this fit into your world? And at Clemson, it fits very well. We're going to get so much net zero credit out of our next building. We've gotten it out of the existing ones. We have a chapel. We have the Andy Quattlebaum Outdoor Center. Both were paid for non-state funds. An alumni donor center, that's not paid for on the books. But the new building we're building now is state money, and we're gonna really come home with it, I think. So net carbon benefits, and find out what your students say, because a lot of them have heard about this material, and they're very interested in having it on their campus. Utilize your state and local resources. These are a list of resources that you can find. Woodworks will take your building and look at all the engineering and tell you if it makes sense or not, if you've got an existing drawing. State foresters, ThinkWood, they have lots of materials where you can read and think about, just articles with case studies and all of those kinds of things. The American Wood Council is working on designs. They also have the website where if you know this sawmill, you can click and they will take you straight to where that sawmill is and tell you about the wood. Other universities, Clemson Universities, and I think there are now 65 educational buildings. And the first one, actually, that I'm aware of that was a fairly sizable building was actually a K-12, one of their buildings in West Virginia. Who knew? But they have an incredible building there. So lots of opportunities for helping. If you are interested, we'd love to have you come and tour our buildings, and we're doing construction right now, so happy to help and have you think about it. Just to give you an idea of what it takes, I've given 3 buildings. The Quattlebaum building, ours is the bottom, tiny building, 16,500 square feet. It took 354,000 board feet of mass timber, part of that, and then 72,000 board feet of glue lam beams, about 282,000 board feet of CLT. Now, I've calculated, and if I grew all the trees in 1 acre and I used every bit of trees, I could have done it with 28 acres of trees. I think it probably took about harvesting of probably 100 acres just to get it, because you know what? Not one single product comes from a tree. We get dozens of products from a tree. So the bottom log may give me, if I cut it at like 16, 17 feet long, it'll give me regular 2x4s. It'll give me beautiful CLT 2x6s that don't have any knots. The top of the tree, the next log up may go to make OSB for somebody's house. And finally, there may be a part of that tree that goes to a pulp mill to make paper, or it goes to another facility for biomass energy. So we don't have a lot of waste in our world. At least in the southeast. I can't speak for the northwest. I don't think their logging works out with some of their tops, but we do a really good job of utilizing every piece of wood that we can. And in the sawmill, when we're sawing up wood, there's definitely no waste. Nothing goes to a landfill from these mills, unless it's the dirt off the floor. Anything that's wood gets reused. So Plat 15 is in Denver. This is your UMass building. I got these from Woodworks, so I hope that's right. It didn't take a lot of wood for that. It doesn't, believe me or believe it or not. And I know where his wood comes from because it came from Quebec, and I know that Plat 15 came from northern Quebec. And the government of Canada, believe me, and Quebec have a really good handle on what they've got going out there. So this is where my building wood came from. This is Smart Lam. The SL is Smart Lam. It's in Dothan, Alabama. SWS is Structural Wood Systems. They made the glue lams for us. And I know that one of the Canfor C mills provide all of the glulam wood, and the others, Rex Lumber, Harrison Lumber, Canfor, and Interfor, all supplied wood to Smartlam for our building. Now, this is the advance of how the wood mass timber building has gone around the country. So we're just going to sit here just a second. My timer's not working, so I'm going to be off in like 1 minute, I think. But that's how it's growing. So there's over 4,000 buildings now either already built or in design. They're around the country. They're almost in every state. And so I think Nevada may be lacking one, and there's some planned for Nebraska if they're not there already. These are where you can find manufacturers or where you can go look for sites. So this is a Wood Innovations Network site. You can actually go in, click on a site, name your state, give your zip code, and they will tell you the closest buildings to you so you can go see them. Because you won't believe it until you walk in. Most people don't. They look at me like, crazy girl. And then they walk in and they see our buildings and they're like, I can do this. This is just a little bit about, we have enough wood, yes we do, and who grows it and all of those kinds of things. This is our newest building. It is a hybrid building. This is an Alumni and Development Center. It's 2 steel boxes connected with mass timber. So if you don't want to go all the way, go a little of the way. It really reaches out and means a lot. It's big in donors. They love it. Now I'm going. Okay, so that's why our development people chose. So the top story on this is all mass timber above your head, looking out on a lake. Boy, you want to talk donor events in that place? It's going to be gorgeous. Golf course right in front of you. Yeah, it's going to be great. We're excited about that. And this is the last quote. I love Frank Lloyd Wright, and when I read this, it made me love him more. Wood is universally beautiful to man. It is the most humanly intimate of all materials. This is biophilia. People feel better. They are less stressed. They work better. Everything moves smoother when you're in one of these buildings. And people in Atlanta are now paying $20 to $25 more per square foot of rent just to be in a downtown Atlanta building made out of mass timber versus a traditional building. So there is dollar value in this. People respect and admire it, and I think people like to be around it. My Andy Quattlebaum building, everybody says, well, it just smells good. And it does. But it really is a pleasant and wonderful place to be, and you just feel at ease. And that's what we want for our students when they're not studying. They're in their learning. And it was the best thing since COVID because it was all Wi-Fi, and the Wi-Fi kind of reached out, and they could camp out around the Andy Quattlebaum and be semi-secure during COVID. So it was a really lucky piece for us. Thank you. I can take maybe one question before we have to close for lunch.
We do have time for one question.
Okay. Thank you.
Do we have any?
Well, let me
You gave them everything.
I gave them everything. I want to put a special thanks out to all of you who already have buildings on campus. It took courage to do that in a time when nobody else was doing it, and I really appreciate you doing that. All of our landowners in the United States, thank you for doing that, because this is important to them and to our forest and to our national forest. So really, keep building, because we need you to do this so that we have room to grow more trees, to suck up more carbon, but more than anything, keep those buildings living long and storing carbon for another 100 years, because that makes a tree stay a lot longer in the business of climate change. Thank you.